Okay, we've looked at the first few steps in the scientific method, and I just want to briefly say a few words about the kind of data and the kind of evidence that we use in psychology studies. So in the fifth step, the researcher is going to analyze their data and interpret the results. And once again, it's really important that the data that we have are things that are observable, measurable, quantifiable. And this is why the scientific method is so important, because it allows us to understand things that are objective, that are not anecdotal or subjective. And the difference here is if I was going to measure health, and let's say that I have a set of variables, and they're things like blood pressure, weight, for example, then those are observable variables. You can have 10 different people measure somebody's blood pressure, and all of those 10 people should come up with the same measurement if they do it at the same time. You could have 10 different scales that assess someone's weight, and if the scales are accurate, the person should weigh the same on all of them. So that's an objective way of measuring. A subjective way of measuring. We do use subjective reports in psychology, but we don't rely on them exclusively. So a subjective report would be, well, for example, you could ask somebody, how much do you weigh? And we know that people are not always accurate about that. They maybe don't know how much they weigh. They maybe never weigh themselves and they simply don't know, or they are embarrassed about how much they weigh, or they think they should weigh more or less, and so their report is actually inaccurate. So that's a more subjective measure, and we wouldn't want to rely on that exclusively. Although psychology does use a lot of subjective data, it doesn't rely on it completely. And the other thing that psychology doesn't rely on, and the scientific method doesn't rely on, is the use of anecdotal reports as data. There's a place for anecdotal reports. These are people's stories or ideas or opinions about things, and there's a place for that kind of data, but once again, not exclusively. And science cannot rely on anecdotes because anecdotes are individual and subjective. If you ask people to report on their experiences and you have 100 people who all experience the same event, you may get 100 different reports. And remember that what we're looking for here is accuracy, not opinion. And that's why we tend not to use that type of data. Okay, so we've used all of the steps in our scientific method, and we're now down to the last step, which is reporting on your findings and deciding on what to do next. And reporting on findings is all about sharing them. And science is not a private enterprise, it's a public activity, and scientists it's very important that they share their findings, that they publish or present their work so that it can be commented upon by their peers, other people can learn from it, and everyone's work contributes to a body of knowledge about something. If you think of science, it's a bit like a snowball, and the snowball is what we know about a particular field, and the snowball is kind of rolling around, gathering more information, getting bigger as it goes. That's essentially what science is like. It's a public activity so that everyone benefits from the sharing of knowledge, and the knowledge contributes to how everyone in that field does their work. It's important that there's a peer review of the science that gets published. That means that when a researcher sends a piece of work off to a journal to have it published, before it actually appears in publication, it'll be sent to peers of the scientist who will review the work and make sure that they in fact are correct in their conclusions, that the work was done properly. And it's actually very difficult to get work published. It's a very it gets scrutinized very closely before it appears in print. The other thing that sharing the research does is it allows other people to replicate the findings, which means essentially repeat the research and get the same conclusion. And this is also very important. You can imagine that if you were to be prescribed a drug by your doctor, you'd want to know that that drug had more than one study showing that it actually had the effect that you think it will have. So it's very important that all of these research findings are out in the open. And unfortunately, what tends to get reported most often are positive results, results that support predictions and hypotheses, and what tends not to get reported so much are pieces of research that don't tend to support a hypothesis. Anyway, that's the scientific method in a nutshell. 6 basic steps. You should understand how these steps work, and think about how if you had a question about something in the natural world, how could you turn that into a testable hypothesis and design a piece of research that would test that and see whether that would work. Okay, let's go on.